We're started. Wait. You're live.
Okay, welcome to part 2. After a nice nougat and cookie break, we are back ready to begin anew with CyberWizard Building a Web App Lecture Part 2, the browser. So after talking with some folks, I think a good direction for our CyberWizard Witchcraft and Wizardry student management platform is to add a chat program to it. So maybe what we can do next is to use this thing called WebSockets, and I'll show a bit more about how those work, to have each house have its own secret chat room where they can talk with their house pals, discuss their coursework, and share tips and tricks and all of that kind of fun stuff. So here's our application like last time. If we go back to the home page, it's all still there. So if we go to our houses list, I think a good thing to do, there we go. So here's our list of houses. Maybe if we click on a house now, we can add a link that says chat or whatever. Or maybe the chat program could be type your name, and then from the name it figures out what house you belong to, and it would route you to the appropriate house channel. But I think for now, if we just, from the house page, decide which chat room to go in, that'll work pretty well. Okay, so there are a lot of libraries to build a chat. One of them that I like to use is called WebSocket Stream. So this is a pretty bare bones implementation of the WebSocket API. The WebSocket API is a little bit clunky, but basically how it works in the browser is you can listen for these message events, and the server can send messages whenever it wants, and the message event will fire in the browser. And the browser can also send messages back to the server with the send method, and then the server can read them. So we could implement that directly with the APIs, but this module, WebSocket-Stream, is nice because we can use streams, which are a handy API available in Node that we can also use in the browser. So here's what it looks like to use a WebSocket connection. I think before we do that, we can play around a little bit with a little quick demo app in the browser. So the first thing we could do is if we go into our browser directory we created last time, we can make a file called main.js, and we'll just require the WebSocket stream library. So WebSockets-stream, we'll say that to a variable wsock, and now maybe we'll just put that on the window object, and you'll see why in just a second. So the window object is this global that's always available, just so that we can play around with this in the command line a little bit. Okay, so if we have this program, this is browser code, but we're using a require function. So to make that work in the browser, we can set up some tooling. So if you do npm install -g browserify, and you might have to put sudo in front if you haven't configured npm, you'll get a browserify command. And if you do browserify browser/main.js, then you'll get on standard out all of the code that it would take for that file to work. So in here we're doing a require WebSocket stream, and all that Browserify is doing is providing that WebSocket stream module and all of the files that requires, so that we can just run this code from a script tag. So how you wire this up is you type Browserify, the name of the file or files that you want to find all the require calls and stuff into your output, and then you can use a shell redirect with a greater than to write that to a file. So we'll write that to public/bundle.js. And sometimes it takes a bit. Okay, so now we have a file in public called bundle.js. There it is. In our HTML, we can now add a script tag. So I like to add a script tag at the bottom of the body, because then you can do document.querySelector for whatever else happened before the script tag. So if we do script src equals /bundle.js and then /script, we'll be good to go with our code. So now, if I just reload the page, if I open a debugger, I will have the WebSocket function from that module defined. So I can make a new WebSocket connection by calling the WSock function with a specially crafted URL. So WebSocket connections start, you know how HTTP connections start with http:// WebSocket connections start with WS or WSS if you have an SSL cert. So we do WS:/ localhost. We could connect to 5,000, but we're not actually doing any WebSocket connections on the server yet. So we can instead use this little program called WSNC. You can npm install -g WSNC and you'll have it. What it does is it's just like Netcat. So you can do -LP to listen on a port like 5001. Then in another terminal, and I'll just make a little terminal here so we can see what we're doing, you can then WSNC WS:// localhost 5001, and you can say hello. Likewise, from your server, you can say, I am the server. Rawr. Hello, server, says the client. So it's just like Netcat, but it's using a different protocol. But just like Netcat and a raw TCP connection, it's a bidirectional, full duplex communication channel. So both sides of the connection can send whenever they want, and each side can receive the messages right after they've been sent. So unlike HTTP, which is more modeled around a request-response cycle, so you request a document and you get back the entire response, WebSockets are more like a TCP model where you just have a connection that stays alive and you can send whatever information you want over that pipe. So if I rerun this connection again, from the browser we can speak to this WebSocket server directly. So here we go.
How'd you get that box to come with them?
It's just a terminal. Anyways, oh, the debugger?
Control-Shift-J.
Yeah, Control-Shift-J to open the debugger. So we can create a new WebSocket handle by doing WS equals WebSocket in the URL. And now, because WS is a stream, as the name WebSocket-stream might imply, we can do ws.write and send a message. Hello there, server. Now if we go back to our server, we get the message, hello there, server. So if we want to listen for messages in our client, there are a lot of ways to do this, but a simple way is to use a on data listener. And we can just console.log data equals from that data listener, and now if we send a reply back, hello browser, and there's our data right there. So we have this bidirectional communication mechanism set up just from the debugger. So the next thing that we can do is start to build up maybe an interface for doing a chat for each house. Okay, so to install this kind of a WebSocket server into an existing HTTP server is fairly straightforward. In your server code, the first thing you can do is var wsock equals require WebSocket stream, like that. And then, like at the bottom of your file, after you've already set up your server, you can then do wsock.create server. You have to give it an object where you pass in the server, the HTTP server that you want to listen on, and then you pass in a callback as the last argument. And inside of this callback, we have access to this stream. Stream is just a full duplex connection, just like we did with net.create server, but this one speaks WebSockets. So once we have a WebSocket connection in our HTTP server, we can talk directly to our server. So a simple thing that we can do to start with is just, once a WebSocket connection opens, we can just send a static message. So if we do stream.write, hello with a bunch of exclamation marks and a new line. So now, in our browser code, if we go back there, remember we had just this before, so let's set up a little listener for data, and we'll just print out what the data is. So you can read more about this from the Stream Adventure Node School lesson, or also in the Stream Handbook, but all streams have a data event you can listen on. And then we can just print out what the data, or what the buffer is, like that. Okay. So the other piece that we need is we'll need to rerun Browserify. So we can rerun Browserify like we did before, main.js, put it in public bundle.js, but this is a little bit difficult to remember. It's like it's not too nice to be doing this all the time as you're developing. So a nice handy way to set up a lot of this tooling is in your package.json. There's this thing called the scripts field, and in the scripts field we can put whatever kind of code we want to like whatever sort of shell scripts we want to set up to run automatically. So for example, we can make our own script called bundle, and then we can put in Browserify browser/main.js greater than public bundle.js. So now we don't have to remember that big long Browserify command. All that we have to do now is do npm run bundle, and it'll go ahead and run that Browserify command for us. So there's also a package called Watchify. So if we have a watch script that we can run by typing npm run watch, we can run the Watchify command instead. And what makes Watchify different from Browserify is that Watchify will launch Browserify whenever one of your files changes. So you give it a file just like Browserify, but unlike Browserify, you have to tell it -o because it will repeatedly rewrite to that file. So you can't use the redirect in the shell because it needs to constantly rewrite output. And then it's handy to put a /d for debug and v for verbose. And this will just print out handy messages to the command line, like how many bytes it wrote, so you can make sure that it's still running. So with these scripts, another one that I think is pretty good to put in here is if you add a script called start, you could add a node server.js, and then all that you have to do to start your server is instead of typing node server.js, you can just type npm start. It's kind of handy sometimes. So now we've got this server, it's listening, it's not only an HTTP server, but now it's also a WebSocket server. If we run npm run watch now too, then Watchify is going to rebundle our code. So if we change browser/main.js, which I'll do here in a sec. So I'll just add a new line. Then Watchify prints out another message because it recompiled our code. So all that we have to do is edit our files like normal, even if they're browser code, and Watchify will rebundle that script file from our HTML.
And npm is running those files through Node ultimately, like Node servers running.
So what npm is doing is if you install packages like if Browserify was one of our dependencies, so if we did an npm install --save Browserify Watchify, then anything that npm, like these are all of the node modules that npm has commands for. So all of these commands are put into our path. So you can run any of those commands from an npm run script.
Okay.
So if you don't have them globally installed, but you have them locally installed in your package, then you can run any one of those commands or any other bash commands. But does that answer?
Yeah.
Okay, great. So we've got our watch script running, we've got our server running like before, and we have this simple WebSocket connection. We can test this really quick by loading our page, and we should now see a message. WebSock.on is not a function. Right, that's because we actually have to connect to our server. So this will be localhost 5000, but in the browser we have this location object, this window.location object, that actually has some nice properties like host. So if we don't want to hard code our host, we can use this variable in our browser code to connect to whatever port we happen to be listening on. So that's usually better practice than hard coding a string like that. So plus location.host, and then ws.onData. So Watchify is recompiling our code, so all that we have to do is refresh. There we go, we get a message from our server that says hello. and we could send a message back. Now we're starting to get into the code that we'll need to make our chat run. So what we can do as well, so location, the location object has host. It also has some other properties like path name. Path name is the URL. It's like the path part of our URL. It's just like rec.url, but in the client. So if we only want our code to fire on a particular page, like a chat page that sets up our WebSocket stuff, we could check to see if location.pathname is equal to that. We could also use a router to do that for us. So instead of calling router.match on rec.url, we could call router.match on location.pathname, and we can get kind of the same routing that we're used to on the server side for our client-side code too, if our client-side code gets very complicated. So I'll just add a simple thing to start with. If location.pathname equals house slash, maybe we want to have slash house slash whatever slash chat be a valid URL. So to do that, we can use a regex. How about? So I'll make that a reg. Actually, a regex is a bit. What would be a good thinking? Okay, so if we have, yeah, I'll just split the location.pathname by /, and then if parts 0 equals house and parts 2 equals chat, actually that should be parts 1, and parts 3 equals chat, then parts 2 is going to be the house name, or yeah. So then we can create the WebSocket, otherwise we won't create the WebSocket. So only on this page are we going to connect to our WebSocket connection. And then in here we can connect to only that house, and we can only talk to the other people in our house. So that should only fire if we're on a house chat page. So we'll need to go into our router and add a special chat route. So if we have house / name / chat, and actually this has to come before our other route because it's like more custom than our next route. So the name is going to gobble up everything else. So we'll put this one before it, and we'll just say house chat, just for now. Maybe the m.params.name can be in front of house chat. Okay, great. So with this in place, restart our server and go to house cuddlepuff / chat. We see cuddlepuff house chat, and we see a message in the terminal. That's our hello message, which is good. If we go to other pages though, like our house list, then we don't see that. Oh, we do see that message. Hang on. Yeah, okay. I reloaded it and we don't see that message, which is good. But house cuddlepuff chat, and we get our message from the server. So this is good. This is what we want to happen. So now the only part is how do we build the UI so that someone types a message into a text box, we send the message to the server, and the server sends the message back to every connected client. So I think the first place we can start with that is let's build a little form on the house chat page.
Wait, real quick, if you sent another message to that, would it update?
If I send another message from the server? Yeah, but I just don't have that code in the server.
Like in the command line, if you entered, like how you just did, or are you able to just do it once?
Well, the way that I've set it up right now is the code is right here, so we're only able to right now send a single message because that's all of the code in here. But in a moment, we're going to have the ability for anybody in the browser to send a message that gets relayed out to everyone else.
Oh, okay.
Yep. So the first thing we can do is in our router for our house chat, we can have a little form. So we'll make a form tag, and we'll add an input fields, type text, and a submit button, type submit, and then the name of the input field can be message, and the value is chat, maybe we'll also have an input field that's your name, so we can, nah, screw that, we don't need names. We'll just be anonymous and shadowy. So here we have a form. The other thing you can do with HyperScript is you can have little event handlers. So even though this is rendering server side, if we want to render this in the browser, then we can have an onSubmit handler in here, right here. So we don't have to do like a document.querySelector for form and then add event listener submit. We can just have a little onSubmit function just inline right here. And in the server side, this does nothing, so we can render the form and it'll be fine. So we set up a little event. We disable the default handling, which will like try to do a get or a post or something to a server. So we don't actually want to do that. Instead, we want a handle on the WebSocket connection. So we're going to have to pass in a few things before we can make this route work. Like, for example, we're going to have to pass something through this M object or another object. So why don't we set that up right now? So in our browser code, why don't we require a router? We can do that. That'll work. So we're in the browser directory. Our router lives in the parent directory. So we var router equals require / router.js. Now, instead of doing this kind of custom logic, which we could also still do, we can do router.match location.pathname, and if we do some custom logic. Remember that we're going to get virtual DOM elements back from our router calling m.fn. So if we call m.fn with m, we'll get a virtual DOM element. So say DOM equals m.fn. And to add those, to patch those virtual DOM elements into the page, there's this nice module called main loop that I like to use. So, well, we don't actually have to do any of that. All that we need to do is sort of patch it into the page. So we can require virtual DOM, and then do vdom.diff. Actually, it's going to be easier just to use main loop. So let's do that, because I can remember how to do that off the top of my head. So we create a little main loop instance by calling the main function with some state and some state, a render function, and a virtual DOM implementation. There we go. So now in a render function, we get the state as an argument, and there's a little bit of boilerplate here, but I think it's okay. So if we pass in the path name as a location from location.pathname, what we can do is when this render function gets called, we can then call the router on that state.path. And then the render function, how it works with virtual DOM is that's where we return virtual DOM nodes. That's what main loop expects. So we can just do if m return m.fn of m, and maybe we want to add the state object to m because that's kind of a handy thing to have. Else we'll just return a message that's like not found, because that's also handy to have with the div. There we go. Cool, so now we could do this stuff, but actually because we already have a router, we might as well, yeah, that's okay to add. Okay, so the next thing that we can do is if we have that WebSocket logic, we can add that to the state. So if we create our state up here, then instead of just having a variable called ws, we can call state.ws, and then inside of our code right here, we can do fancy things with it. So this will let us send some variables. Actually, scratch that. I've got a different idea for this. So if we make a little event emitter, these are a core abstraction in Node that you can use. This stuff gets pretty hairy and pretty complicated because there's like a bazillion inputs and a bazillion outputs, but that's just the way it is. So, but anyways, if we make a new event emitter like that, then when we get an event, we can listen for an event, like a message event, right? When we get a message, we can just send that on out. We'll write the message directly to the WebSocket, and we'll preface that message with the house name about. So we'll use json.stringify to put the house name in the message. Or the message can contain the house name. Sure. We'll just stringify the message, whatever. We'll figure that out later. We'll put a new line because on our server code, then we can read in line after line and do something special for each line. Okay, so there's our message that we want to send. And now the other part of it is we'll have to listen for messages from the server and update some state. So maybe we'll have a new parameter in our state object that's the list of messages. So we'll just have an array called messages, and we'll push things onto that array when we get a message. So WS on data, we get a line. Actually, there's a handy split module, and this is covered in the Stream Adventure Node School. There's this module called split and this module called through that are very handy for setting up some stream stuff. But basically how this works is we can take our WebSocket, split on new lines, and then do json.parse on each new line, and then have basically a little callback that fires whenever we get a JSON object. So if we get JSON objects back from our server, we can dispatch them to our state. So we do state.messages.push row. Okay, so that's a bit of boilerplate. Don't worry too much. It's kind of confusing, but if you play around with streams a lot, you'll get used to this kind of thing eventually. So we've done all of that stuff. We're updating this state. The next thing we need to do is whenever we modify the state, we need to call this loop.update. And all that loop.update does is it recalls our render function and patches in our new DOM into our state. So the last thing we can do is pass in the bus also. So m.bus equals bus. This is the event emitter that we can use to emit messages when we call our form post. So inside of our router again, we have an onSubmit function. So inside of here, we have access to, this is a form, so we can do this.elements.msg, because we have a name MSG right here, .value. And that's going to be the text that somebody typed with their fingers for the message. So the other piece of data that we have here is the house name. That's m.params.name, right? So var house equals m.params.name. And the message text, so what we want to do is we want to call m.bus.emit message, and then we'll give the house and the message text, so we'll call it txt. Okay, so when somebody clicks submit, this code will fire. We get the parameters from both the route, because we know the information from the route already. We get information from the elements.message.value, which is just what somebody typed. Okay, and that message gets emitted, and then in the browser main.js, what happens is this bus.onMessage event was listening for us to emit that message, and it writes that message out to the WebSocket. So the WebSocket talks to the server, and the server now, as the next step, we're going to rebroadcast that message to everyone else on that house chat. So a lot of moving parts, and finally in our chat, we need to take the m.state and render all of the previous messages. So here we've got the form, and then maybe after the form, we'll have another div that's all of the messages. We'll do m.state.messages.map and then we can call msg.txt. So return hdiv message.text. Great, so we're taking the stuff that we got from the server puts that into the WebSocket puts that into the state, the message state, and this code here will render out all of the messages. A lot of moving parts, but that's just how things are. So right, so the next thing we can do is to restart our server. I also have to, Watchify is informing me that I also forgot to install Split 2 and through 2, so let's do that really quick. Let me just make sure that I have the other packages. Great. Here it goes. Wasn't thinking far enough ahead, so we're installing this. Oh great, it built. Even though that hasn't finished yet, whatever. Okay, great. So, we reload the chat. No data received. Why? Cannot read property map of undefined. This is because m.state.messages is undefined in our router, but that's... So we can just add a little thing here where we m.state.messages. If that doesn't exist, we'll just use an empty object. So that won't crash anymore, hopefully. And we'll reload. Great, so it hasn't crashed yet. We do have an error still. That's okay. That's just in our main code somewhere. So one nice thing is with Watchify, we can click these errors and it will, oh, that's not very helpful, but there's some error somewhere. Sometimes if you reload it, you get a better error message, but not always. So with debug mode, there we go. Browser.js, line 62. That doesn't help. Okay. Anyways, I think the problem is that's defined. The problem is possibly in our router. No, it's not. Well, I already remembered one thing that's wrong. So we've got to actually insert our loop into the DOM. So there's a thing loop.target that I forgot to set up. This basic setup, by the way, is I made a starter repo that's linked to in the web app notes on the Cyberwizard workshop. It's called Virtual DOM Starter. There's another one called Virtual DOM Universal Starter, and these have a much more simplified version of what I'm showing here with lots of moving parts. So what we want to do is we want to document the query selector for our container ID, I think it was, content ID. And we want to replace the content in there with our loop.target value. So I think we can call replace childs, loop.target, and then the content.child node 0. I think that might possibly work. We'll see. Expected token H. Okay, I don't know why it's having that error, but well, let's just type a message, see what it does. So we click chat. Still getting that weird error. Chat line 1. Let's go in here to bundle.js and make sure that it works. Okay. So let's just copy this and xclip-o pipe to node to make sure there's no syntax errors. Great, so that is all good. This is slightly puzzling. Oh, I think I know what it is. Our JSON messages from our WebSocket. Remember how we sent that message hello from our server? Guess what the first character is in hello? It's an H. That's where that message was coming from. So we were parsing JSON from our server, but we actually forgot to send JSON from our server because I hadn't gotten to that part yet. So let's get to that part right now. Great. So the next piece we can do is edit our server. So right now we've got the basics that possibly might work for our chat program. So what we need to do next is, okay, so here is our basic code that's going to handle incoming WebSocket connections. So we get a stream, and we can write to that stream, preferably with something that's not an invalid JSON object. So just like in our command line code, we can require split to and through to do some basic stream parsing. So require through to. And so we can take our stream, pipe that into split, and pipe that into JSON.parse. We should check for errors, because if we send invalid JSON, we'll crash the server, but I don't care about that right now. So instead, we will just pipe into through to get objects. And then we also want to listen for close events on stream. So when stream ends, we need to clean up a list. So what we need to do basically in our server code right now is when we get a message, we need to broadcast that out to everyone else who's connected. So we need to keep track of who's connected. So a simple way to do that is just to keep a list. So var streams equals empty array. When somebody connects, we need to push that stream into our list. When somebody disconnects, when the end event fires, we need to take it out of our list. So we can do streams.indexOfStream and call this method, this built-in array method called splice, that just takes out an element. So that deletes that whatever element is in our streams list. So great, and now we can make a function that will rebroadcast everything that gets sent from the clients.
So is that stream on end an event listener?
Yes. Yes, so when the stream disconnects, that event fires. There's actually a more robust way to do this with a package called end of stream, but I'm not sure.
So there'll be some kind of call, like called end, that like as the event loop comes around, it'll see that, and then it'll trigger the event.
So like basically, the stream on the remote end will end. In some case, it'll like be finished. Mm-hmm. Like if somebody closes their browser, and then the server just gets notified of that and can take the stream out of its list. So inside of our write function now, we can loop over all of the streams.forEach, stream, and then we can stream.write JSON.stringify row plus new line. And then after all of that, we call next. So you send a message to the server sends the message back, and the client code should then render that message, hopefully, if we've done everything properly. And no guarantees that we have. But that should be all that we need to do, except we need to check that the house is correct. But I'm going to cheat a little bit and check that in the client instead of the server, because it'll make for a simpler thing to do. Even though, strictly speaking, anyone could read all of the messages from like their other house pals, because the messages are all being sent to the browser, but I don't feel like doing that in the server right now. So let's just make sure that this all works first. So we can restart our server. Good so far, hasn't crashed. Browser code looks good, no syntax errors. I'll reload the page. No H error, which is good. So now I'll send a message. Hack the wizard planet. Invalid non-string buffer chunk. So let's quickly debug what could possibly be going wrong there. So our JSON parse part is probably what's messing up here. So invalid non-string buffer chunk means that we're trying to send an object into our WebSocket connection, and that's not something that we can do. So let me think. So we're calling pipe on split. So this is because you have to do through.obj if you have objects, which is kind of silly. I think I forgot to do that in the server as well. So, oh no, I remembered in our server code. So that's just a quirk about through and object mode, because it's meant for sending buffers, not just objects. Anyways, if we restart, hack the Hogwarts chat.
Yay.
And it appears. And check this out. So if I open another browser, oh my goodness, this is going to be hard. So if I open another browser, to the same page, we see the message on both browsers. And so if you go to my IP address, if you're on pseudomesh right now, which is 192.168.190.237, port 5000, I'm going to paste it in IRC if you're there.
Wow.
Then you too can chat, and actually let me send you a better link that includes the, we'll go in the House Cuddlepuff chat, not that I'm checking. So please do click that link that I posted in IRC, and we should start to see each other's messages. Yeah!
This is incredible.
Great. So
npm start runs all the scripts that are referenced in your package.json.
So npm start isn't anything special. All that npm start runs is whatever script you defined in here. So I typed nodeserver.js, so that's what it runs.
Okay.
npm start is just shorthand for npm run start, which is shorthand for npm run script, run dash script
I know
start.
who did that.
Cool. So people are having fun with Cuddlepuff House chat. I haven't implemented the part where the houses have different chats, but you get the basic idea. So I think that's probably pretty good for today. Another fun thing actually we could do really quick is you notice that when I click a link to somewhere else, it actually reloaded the page. I can make it not do that because I was secretly writing all of the router code the whole time so that it will run in both the browser and the server. So we're already just requiring a router in the browser. So what we can do now is we can check for when someone clicks a link, we can actually just re-render the page according to what was in that link. So let's do that really quick. So there's two modules that I wrote, but whatever. There's probably more online, but these are very simple. One is called single-page. The other is called catch links. So how single page works is so you define a function. So you call single page with a function that takes a URL, like the page ref. This is like the location.path name. And it returns a show page function. Whenever you call that show page function, the address bar will change, but you won't have actually gone to that URL by loading it directly. It's just, it looks like it changed, but you're still kind of on the same page, sort of. So you can make really slick, really fast web pages that the URL bar might change, but it's not actually requesting anything. So this is a much faster way of doing stuff. Another nice thing is that you can keep all of the state. Like, we're keeping all of the messages in that state array, so we can go to another page without resetting that. So this is like, for example, how SoundCloud can keep playing a song even though you're clicking around in their UI. They're using this API that's called push state behind the scenes to achieve that. So this module can do push state for you as well if you want to do that. The other package is called catch links. So you remember how you can do oh, that's cool. Remember, oh yeah, I see why that's in there. Remember how you can do window.add event listener click and then function ev, and then we can log ev.target. List 10er. Okay, so now when I click the page, I see that I clicked H1 Cyber Wizard School, or when I click that home, which is not a good place to click, but I'll click the UL tag. I can click this input box. So you can see what you've clicked. If you click a link, the target name is going to be an anchor tag, an A tag. So you can actually list that by doing .tag name. So this is going to show whatever tag name we click. So divs or inputs or whatever in caps, I believe, but it's good to convert that to uppercase. Anyways, the catch links module does that, and it will automatically give you a callback that you can use instead of the default clicking on links kind of behavior that happens in the browser. So if you combine push state, clicking on links, you can navigate to different pages without actually reloading anything, which is a really nice thing to do. So let's wire that up. So the first thing you can do is once you've got a loop and a state kind of hooked up, you can require a single page. And then you get a show function back from single page once you wire up ref. So the reason why you have a callback here is that different push pop states might occur. So when you first load the page, there's an event, and when you navigate to a different page, there's different events. What we want to do is, because we already have a state to manage what our location.path name is, we can set the state.path to be ref and call loop.update, which will recall our render function with the state. So a lot of words, a lot of moving parts, but that's just the way it is. Deal with it. Okay, so next we can require catch links. So var catcher equals require catch links. You can't var catch because that's a reserved word in JavaScript. It's part of try catch, but catcher is a fine name. And if we pass catcher our show function, then this will be all wired up. We could even just do it like this to be more concise. So the catch links function is going to call our show function, which accepts a URL that we want to navigate to, and we want to put that in the address bar, basically. So when we click the link, it'll look like we went there, but we didn't actually. All that we did was update the state.path. We re-rendered the page, and because we're using a router, and because we're calling m.fn to our router code, and because our router is returning virtual DOM nodes, and because the render function expects virtual DOM nodes, because of all of those things that we just did, then this will automatically just work. So with that little bit of code, okay, so now if I reload, so it reloads like normal on the browser. Zip root.add event listener is not a function. I don't know why that is. Index.js line 4. Oh right, sorry.
Still running. Works for me.
Oh yeah. This is so I forgot. Catch links takes an object that you want to listen to as the first argument. I've done that a lot of times before. Okay, so here we are running. People can still chat. That's good. Once I click home, apply to be sorted. So I don't actually have a route for home. That's why it says not found. But what I'm doing now is I'm rendering things in the browser. So let's just add a few things now to our index.html. Actually, first I'm going to add a route for home. Router.add route / function m return h welcome. There we go. Okay, so reload. Click home. It says welcome. Now I'm clicking around, right, and the URL is changing. But if I were to go into my server, or like, what if I were to stop my server? I can still click different links, and it still works.
But on the back end, you're not actually going to a different URL?
No, I'm just re-rendering the page for different locations. So even though our server isn't even running anymore, we can still go to those different subpages because we're not actually talking to the server because we have all of the content we need for those different routes. Cool. So I'll restart the server so you can all talk amongst yourselves again. Oh yeah, maybe the last thing we could add real fast is just some different links to our page. So I'll put a links to the houses, and then on each house page we can add a link to the house chat. Really fast. So chat, or rather the house name, because I didn't do that previously. So I will make the image to be a link. So href equals m.params.name, but it's houses or house slash m.params.name slash chat is the ref, and the img tag can be the value. Okay, so restart 174. So, oh, there's a comma where there should be one. Okay. Great, so that's running. If I go here, I'll click houses, I'll click dragon door. Whoops. Cannot read property map if undefined. That's because m.state.students wasn't set. So we could populate that, but I'm feeling lazy, so we're not going to. I'll just rerun it. There we go, house dragon door. If you click the link, now you're back in the chat. Rawr. But I might have broken something. That's okay, whatever. It worked before, so. Go to Cuddlepop chat. Oh, maybe it does work.
Was it just one chat that was set up?
It should have been all of them.
I didn't see your hi on Cuddlepop.
Okay, I think I might have broken something in my haste, but I think that's pretty good demo. I mean, we got stuff working. We got a lot of different pieces all moving along. So I'll commit all of this to the workshops repo, and I'll have some more notes later tonight. Also, try to have that regex node school adventure up pretty soon if you want to learn more about regex. So thanks.
Woo!